coffee grabbed. Good morning, YouTube. We are continuing on our series for preparation of Advent of Code 2023. So we're continuing by preparing by doing Advent of Code 2022 and kind of working out some of the kinks. Today we get into day 5. I will say I've attempted to make this video once or twice because I had some ideas on how I was going to approach parsing, and I really just overcomplicated it. So we're going to start again from the beginning and things will be good. So day 5. Day 5, supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of careful planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates in the rearrangement procedure, your puzzle input. For example, in this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Crate Z is on the bottom, so on and so forth. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above rearrangement procedure, 1 crate is moved from stack 2 to stack 1, resulting in the configuration. In the second step, 3 crates are moved from stack 1 to stack 3. Crates are moved one at a time, so the first crate to be moved, D, ends up below the second and third crate. So that's kind of important because if you look here, D and Z starts on the left, and everything is being moved from column 1 to column 3, and they get stacked ZNDP. So the string is, the way that I'm thinking about this is that as we move each stack, we're going to reverse the string. So I'm really just going to do string manipulation to represent the stacks because I just see D and Z as a set of strings, and then I'm going to move, let's say, some set slice of string or indexes of string from 1 to 3, but in that process kind of reverse. I don't really want to move them one at a time, D and Z, because I think that'll be less efficient. Instead, I'm just going to strip out the string I need here, put it over here, and kind of swap that. We can kind of read through. There's just some more examples, but to save time, I'm just going to get to it. The elves just need to know which crate will end up on the top of each stack. So after all the moves are done, we've executed all the moves. We got CM and Z in this particular test example. And then so our input for the test case is CMZ. It'll be something else for our puzzle input, but I want to solve this problem. So I did mention at the beginning of the video that I attempted this previously. I didn't really get to this part of it. I just had an attempt at regexing the input and splitting this apart, and I got kind of into what I would consider the pain of regex and overcomplicating regexes to parse this apart. So that's why I'm re-recording this video. I kind of took a step back, took a break, just kind of rethought through this process. And I decided that instead of, we're still going to use some regex, but instead of trying to look at this contextually whole and then regex and get crazy, I'm just going to split this into lines and do line by line parsing. And whenever we see a blank line, I'll know that that's a transition from my stacks to my moves. I suppose I could also use an integer check, but I think a blank line should be sufficient. We do have to toss this line as well. So one thing to note on the construct of this is that there are equal number of characters between all the lines. So even in this case, there's an empty character and an empty space for each square bracket, which is really nice for our parsing. We can write something that kind of handles that. So I have some boilerplate code kind of set up here as far as some test input, I decided to go from a file. That way it kind of matches what we have today. And what we're going to do here is just process in this file, and we're going to parse it. So my approach previously doesn't really matter too much, but what we're going to do is we're going to split this just by line. So we're going to do a strings dot split. We could use an IO reader and do like a read line type thing. That might be better, but in this case, I'm being lazy. So we're going to be lazy and just do it that way. All right, so now we're going to have everything broken up by line. So there's really one major distinction, and that is when we're processing these lines, am I in the stacks mode or am I in the moves mode? So if we look at our sample of our input file, stacks is what comes first, and then input the moves is what comes kind of second here. So how do I want to represent that? Well, we know that if we've got an empty line, so if line equals, we're no longer in stack mode, we're in move mode. So this can kind of be our trigger to say like, hey, from this point forward, let's process the line as if it is a stack or if it is a move. And so there's a couple different ways we can do that. Since we're in this for iterator, we could just create some sort of like Boolean. And so we could just do stacks complete false. And we can say if line equal that, then stacks complete equal true. And we know that, and we'll continue that. We'll just leave that at the top of our loop, and we'll say if not stacks complete, process stack, process line is stack. And then our default will be to process line as move. So this gives us a way to iterate through, chunk off our first set, which is stacks, and then chunk off our final stack, which is for moves. So I'm just going to create another function here called parse stack, and it's going to receive a string, and it's going to return back a string or a set of strings. I'm going to have this just go ahead and receive the stacks, which is a slice of string, and for lack of a better, this is just going to return stacks. And that way we can pass the stacks in each time. So this is going to simply do parse stack. It's going to put in our line, which is the line that we're coming in with, and then our current stacks. And so we're going to do some sort of parsing there and continue. And then we're going to go ahead and do something similar for parse move. That also has a string, and this is going to be moves, slice of move, return slice of move, return moves. Okay, very similar. So this is going to be based on what input comes in. We'll dictate what goes out, and then we'll just simply call it parse move. S moves. That's my fault. This should be a string. Okay. So we're going to have, that's going to represent it as each individual line. Sorry, this should be line. And so we can think about that as this as each time we call parse stack, parse stack, parse stack. We'll call parse stack here, but we can just get rid of that line. This puts it into stacks complete, and it's going to be parse move, parse move, parse move, parse move. Okay, so with that being said, how do we accomplish the parsing of the stack? So let's create a test. Well, I guess we already have this one. We can just keep iterating on this one. So not ideal. It'll work. We could test the individual functions. That'd probably be smarter, but I don't really have a lot of time this morning. So we're just going to run with what we got here. So we can see that our expected and our actual for the strings is not right. Neither is the expected moves. And I do want to kind of define what those should look like. So let's do that. So we've got count. If we open up our test input and I'm gonna split this right. Oh, we can see it as we're coding here. And we know the first one, it's one move, the from, to, and then the to is one. And so we can probably actually copy these, and then we can do something like line these up. All right, so this is the count. All right, and then just to make this a little bit more readable, all right. There we go. Okay. So now we know what our expected moves are. So let's run this and we'll see not only is the stack's not correct, but the moves are not correct. One thing to know on the stacks, I am expecting them to be a string that is just represented like this, and our move operations will handle moving and appending just those strings. We don't have to make it more complicated than that. We could create a structure that looks exactly the same as the picture, but that just seems like extra effort for a little gain. So that's the plan. So let's look at this and let's say, okay, how do we, I have a bad habit of going to main dot go. Let's write our parse stacks function. So we know that we have an individual line, and that individual line has some sequence of characters. And we look at this, really it's 4, 1, 2, 3, 4. Yeah, okay, so these, the input, let's just check our final input real quick just to make sure it matches up. So we can split this by space. If we do that, the problem comes into play with these extra characters. So what we want to do is really just split this every 3 characters, so to speak. So if we take this input here, I'm going to use a tool called regex 101. You may or may not have heard of that, but let me show you what it is. So anytime you're dealing with regex, it's really cool. I use this tool quite a bit, and this kind of gives me a pretty clear picture of what my regex is going to look like. So the problem is we're going to either have a bracket or a space. So a bracket or a space followed by the data we want to capture, which could either be a /w or a space. So /w is any word character, and then the space is a space. So that's our capture group, followed by either a bracket close or a space. And so what we want to make sure is that we're constructing a regex to parse each line, and then that's going to capture the same number of inputs. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know we have 9 groups. And if we go back to at least this sample input, we have 9 rows. As you notice, that also picked up the missing stacks. This is important because we're going to use this to kind of construct a slice. And if we don't have those missing ones, we're going to end up having something that's going to cause some index out of bounds, or we're going to have to figure out where W fills in. And so this is why I use regex 101. It's a great site to just visualize your regexes. And so now I know that I have a regex that'll work on a per line basis. So I can do a stacks RE, and we can just put this outside the function. The reason I'm putting it outside the function is so that it only compiles once. The compile time, while may seem insignificant for a couple of 100,000 rows, it definitely matters for millions of rows. So we're going to put it outside, and we're going to do regex p.must must compile. The reason I use must compile is if the pattern I provide is inaccurate in any way, it will fail at compile time, and we don't have to do any error handling or anything like that. So it's kind of nice. And so then I could do a stacks re dot find all I think it's string submatch, and then our input is going to be our string, and we'll just call length the string for the total amount. And so this returns our matches. And so that is pretty awesome. And so we're going to trust that let's just get a quick kind of like checkpoint where we're at. Let's do that. So if we run our test, we should be entering into this function no problem. Let's see here. Matches. We'll do that, and we'll see, make sure. Okay. Test parse. Parse. And our input. Just make sure we're reading that input incorrectly. No such file or directory. Okay. So it's not finding my data. We might need to go up on directory. Because we're in what, day 5? Oh, we got to go up for commands. There we go. Okay. Got it. So, just to kind of clarify, we are getting some log output, but what is this log output that we're getting? So, we're getting it should be the matched value whenever you look at a submatch. It's what it matched, and then the result. And because the way that we're printing this out, you're kind of missing some context. Let's try rearranging that. So you've got what the pattern that was matched and the actual value. The pattern, the value. But as you can see here, this is what we're we're kind of looking for. The reason is we want those spaces. And so there's one other kind of issue here, which is we got to make sure our stacks are initialized. So what we're going to do is if the length of stacks equals 0, then we're going to set stacks equal to, we want to make sure there's the index positions are there so that when we append to them that our strings are available. So we're going to make a slice of string the length of matches. Yeah, so we can, just to make the compiler a little happier, we can not assign stacks. And then I think, let me just forget this for a second. I don't think that's a major issue. And for what I'm doing, I don't really care. So if it matches or if the length is 0, we're going to go ahead and set it. And then we're going to say for match range of matches. In that match set, the first value is the whole match pattern, and the second value is the actual capture value. So we know that match sub 1 is our capture, right? Yeah. So what we can do is we can say if not equal to empty, because we don't care about empty, right? We're going to, and what's important here is the index. We're going to append stacks sub I equal to match sub 1 plus equal match. Okay, I might have that inverse, but we're going to go ahead and run the test and see what we get here. Let me get rid of this fatal message. So it's just for testing. All right, let's see here. Expected, actual. Yeah, okay, so we're getting back an empty string. So why is that? Because we need to stacks equal to parse stack. Okay, so let's run this again. And we've got D and Z versus burst. Okay, let's look at our input again. We shouldn't have, we should have DCM, so that's right. NZ and P. Okay, I need to fix my test real quick. So this should be NZ, DCM, and P. Okay, that's the first part. Now, the last part here is I don't need these numbers on here. So that's that. If we look at our test input, that is this last line here. I'm trying to make this dynamic because my actual input is going to be different. And then I don't know if my secondary input is going to be any different. So I want to make sure that that's handled. So we can also, that's fine. We'll just put a check in here. It's kind of hacky, but we're going to go with it. Sub 0, sub 1 equals 1. Return stacks. Okay, so we're just saying if if our first value is a 1 in our matches we're going to return. So let's run this again. And we have resolved the stack config. So now we just need to resolve the move config. So the moves, also pretty straightforward. Let's take a look at that. I think we're going to use another So one thing I don't like about Go and these kind of global variables is the way you define them is slightly different. Let's look at our test input. So this one's pretty straightforward. It's move some digit from some digit to some digit. So that's not crazy. We can just do something like move /d from /d to /d, and just kind of match that pattern, and then use the same kind of setup here. In this case, we don't have to do anything special about like the number of slices that we have. We just know it's a slice of move. So we can just simply return append moves something like this. Counts is going to be, we're just going to find string submatch. So that should be the first set. And then we can simply do, because these are string to int conversions, which again, in this case, I don't have to do, but I'm going to do string convert dot, what is it, a to I, and it's going to be match is sub 1, and call it count. Don't really care so much about the error, and then from and to, from to count from to. Okay, so that should be it. Shouldn't need that. And this is moves re. Okay, let's give it a shot. I had the same problem I had earlier, which is moves equal to moves. Okay, perfect. Look, all right, so now we've parsed our data successfully. That's a huge accomplishment. We've got a data structure that we can work with now. So now the question becomes, with this set of input, what is our expected outcome from the moves? You know, we could, this is bloating the test a little bit, but I don't want to spend more time in this than I need to. So we're just going to do an expected after moves, which is going to be a string, a slice of string similar to this, and we can take this and we can say after moves. And we know that if we go back to our input here, our expected after moves is CM and then PDNZ. So CM and then PDNZ. PDNZ, is that right? PDNZ. Okay. So that's our expectation after our moves, and I'm just going to rename this to test AOC instead of test parse. And we're going to do that's fine. Test parse and move. And then, so then our all right, so we'll create a function called make moves. And that's going to be our stacks, which is a slice of string, and our moves, which is a slice of move. And we're going to return a slice of string, just so we know where we're at. And then so we can say for move and range moves. Okay, now we've got our moves set aside. Let's take a look and see what we're going to do. So we know that we've got a number of things we're going to move from 1 to 2. And so the way our string is represented is kind of left to right. So left being what's on top and right being what's on bottom. And so we know that if we want to move something from stacks, so this is where we're moving from, move.from -1. So this is the slice we want to remove from. And so we want to capture the move data, which will be what we're moving from, and we're removing 3. So we're going to do 0, 3. And then we're just swapping some data here. We're going to set this stack equal to 3 forward, but it's not 3, it's move.count. And then finally, we're going to set stacks move 2 equal to the temp data plus, so that it will, but we need a strings dot reverse. I think this is a Golang strings reverse. I think there's a built-in for this now. I just haven't used it yet. I don't really want to build my own. That was the downfall, one of the downsides to Go. Pretty sure this is a built-in. Okay, we'll use this package. I think we're okay. Not happy about this, but to me it really shows some of the weak points in the language. I thought they may have added this recently, but I guess I'm wrong. Go mod tidy. Oh, sorry, that's just default behavior. All right, let's see here if what I did makes sense. That's fine. Test input's good. We can close that out. All right. This is the test parse and move, and we are expected PDNZ. Instead got ZNDP. Well, I got the move from and to's right. I got the C and M right. But I got these reversed. Okay, so whatever is in my string list. Yeah. So whatever's on the left is on top. Whatever's on the left is on top. Okay, so ZNDP is actually what I'm supposed to have for my ZNDP. So bottom is on the far right. Okay, cool. So now we're gonna change this real quick. We're gonna call this moved, and we're gonna call this get top moved. Okay, and so we're gonna do expected. I should call this top. I'm really kind of shoving a bunch of things into a single test here. And that's not particularly how I do things, but I think I could be a little bit more rapid developing here. So now we just need a func get top function that receives a stacks, which is a slice of string, and that returns a string. And so we can say S is that, and we can say for stack range of stacks, and then I think it'll just be S is plus equal a stack sub 0 return S. I guess it's plus equal. All right. So let's see what we get for that. That matches. So now we just got to pin all of this together. And for our AOC function, which maybe we should have tested from the very beginning, should just simply be parse s, because those are strings and our moves, which we then call make moves, which then returns our stacks after the moves, and we call get top. Boom. So now all we have to do is create a day5.1.txt, and we grab our input, and we put it into this file, and we make sure that our root has day 5 in it. Okay, slight variation here. There are multiple numbers, so we have to change our regex to be a plus here. Instead of a single digit, it's multiple digits. That was not in our test case, and this kind of shows you where testing's cool and all, but you might run into some issues with length 7. Okay. All right. We'll do just a little bit of debugging here. I can read. Maybe I should read through the instructions again. I feel like okay, I didn't see anything. I mean, it was a quick cursory scan. I didn't see anything about there being more things moved. So we'll just print out a message and we'll get an idea of what's going on here. Oh, I'm sorry. That's not what I meant to do. We moved 3 from 9. Or no, I'm sorry, we moved 7 from 3 to 9. Let's make sure my regex is right. Just before it should be, but let me remove, which is our count, which is the first match, from, which is our second one, and 2, which is our third. Okay, all that looks good. Okay, don't think there's an issue there. So move 7 from 3 to 9. So if we look at our input, we made some moves from 4 to 8, and then from 8 to 4. Okay, so we moved 2. Gotcha. Okay. from 4 to 8. Supposed to move 2. So right now there's 1, 2, 3, 5, 6, 7, 8. Okay. This move does not seem to have been reflected then. Because from 4 to 8, count 2. So make moves. All right. I don't think that's right because so 0, 1, okay, 2, 3, 4. Okay. That is not working correctly. Got it. Why not? Let's go to regex 101 and figure out what issue I got going here. It's it definitely seems fine there. This is before you need to make moves. definitely looks like the right number of spaces. Why is my stack? One, two, 3, 4, 5, 6, 7, 8, 9, 10, 11. TVJ WNRMS VCP QJDWB PRD HFJB DNAM BTP RVH BC LPRJB TLSCM. All right, this is where it's getting out of shape. I think it's getting like, yeah, so it's like it's doing like a partial grouping here. It's getting out of sync slightly. So how do we rectify that? The answer is to add this final S because some of the regex was getting offset with that last S being unsure. We just have to make sure that the final line of the stacks has a hard return, which it does. So we want to make sure our test input matches that. And that should get everything back in line for this input. So if we do that and we run this, apparently I've broken everything. Expected was NZDCM-P, and we're missing the P. So we're missing this ending one here. That is because we're splitting on... Okay, this is kind of a simple solve, and I'm going to hack it, but the reason why is we're splitting on the line end, and so we don't have the line ends on the individual lines. And so, well, what I'm going to do is, I'm just going to end each line with an empty space for this. Yeah, that's a bit of a hack. But all right, that's done. So now I suspect, yeah, okay. Let's go back and see if we're right. Awesome. Well, that one's done. That's part 1 of day 5. So as you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a crate mover 9000. It's a crate mover 9001. Haven't we all been there? APIs did not match the specs. The Crate Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, who doesn't need 2 drinks, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crate begins in the same configuration. Moving a single crate from stack 2 to stack 1 behaves the same as before. However, the action of moving 3 crates from stack 1 to stack 3 means that those 3 moved crates stay in the same order, resulting in this new configuration. Next, as both crates are moved from stack 2 to stack 1, they retain their order as well. Finally, a single crate is still moved from stack 1 to stack 2, but it's crate C that gets moved. So do I just remove the reverse? Oh, it's not strings. It's just, do I just, is this the answer? Same puzzle input. Send it. That's it. All right. So I'm going to do just a little bit of cleanup here because I do kind of want to retain like both days or both sets of outputs. So let's see here. All right, so I guess we could label this 9000, 9001. There's a lot of different better ways to do this, but I'm just going to simply my AOC is going to receive a func that is in the pattern of string and moves and returning string. And so now when I call AOC, I can simply call make moves. Oh, I'm sorry. VS Code is helping me greatly. Or I can call make moves, no, reverse. I think there we go. That way I can just top. We'll call this, let's have a little more fun here. We'll go back to our calendar, and this is what the crate mover 9000 and 9001. This is 9000 and this one is 9001. And then I don't want this stacks message showing up in my output. There we go. So now we have this historically. This kind of injection is fine. I could just like have a boolean of like reverse and out reverse. I guess that would also make sense whether or not this gets applied. But I think doing it this way is fine for me. All right, well, that's it. So we accomplished this second part in a very short period of time. As you can see, sometimes these things take a little bit longer, sometimes they don't. I think what I need to focus on getting better at is just parsing the raw input a little bit quicker. I think these types of things are generally a little bit slower in Go because Go is somewhat unforgiving, but I prefer it, so I'm going to keep doing it in Go. Well, I thank you for watching my videos. Please like and subscribe. I'll see you next time.